Hey guys, welcome back. So this is going to be the second day of building Amazon backend. I see almost people are getting in, I think. Yeah, we will just wait couple minutes until more people join in and we will start right away. Okay, and till then, if you have any questions regarding last session, you can ask me as well. And I'm also going to share you the uh, GitHub repository for what we did yesterday. So this repo has the basic server setup of our Apollo GraphQL server. So if you did not attend or you got stuck somewhere, so you can use this GitHub repo and continue on to code along with me. Cool. In case you do not know how you can clone that, it's very simple. You just do git clone and you just paste the repository URL, or you can also go to this URL, right? And you can download the code itself as well. So that's another option for you. Okay, I'll just quickly walk through what we did yesterday, like really fast. Okay. All right. So what do we have here? So we basically have three major files here, right? We have resolvers, we have typedef, and we have an index.js file where our GraphQL server is set up. Okay. So under resolvers, we have couple of resolvers here, which gives us all the products that we have, which is does a simple array here and an add product resolver that adds product to our products are here, okay, which you can then again access with all the products using this resolver. Then we have type def. So this is what basically tells our GraphQL server that what are the things a client or a user can do with our GraphQL server. So it is that you have this type under query, you have this products resolver, under mutation you have add product, right? And what's the input it takes, and what is the return. So it's just going to return a simple boolean right now. Okay, cool. So that's what we have so far. So and then finally in index.js we have this Apollo server created here with our type defs and resolvers. Then we create a standalone server, and once it starts, we console log this server started into our console. So that's what we have set up so far. Let's just quickly start this as well and see it running, right? So I'll do node index.js. And if I go to localhost 6003, we should see it running. Cool. Okay, so what's the agenda for today? So first things first is that we want to learn a little bit about MongoDB and Mongoose and how we can integrate into our app or our server. And then we're going to build few Mongo schemas to which we will be using to basically store our products, store the cart, store the users, and yeah, basically placing order and all that stuff. Although do note that the scope of this workshop is quite limited, so we won't be going deep into user or much of a client side things. Okay, so the goal of this workshop is to learn how you can build a server and how you can build queries, how you can interact, you can basically bridge, MongoDB and Apollo GraphQL server, right? Awesome. Now that's clear. Let's dig into what MongoDB is, right? So just like any other tech that I introduced, we're just gonna go into MongoDB website. So MongoDB is a type of database what we call as NoSQL. What that means is unlike traditional SQL, this is something that's what we call as flexible schema that has a flexible schema, right? It doesn't have a strict schema like you should store only these particular values to this particular entity or all that stuff. Okay, so to put it more into a context, you can think like one user might have a last name, and the another user might not even have that field itself, or or that option itself. So you can think of the schema as like that. It's very flexible, okay? And it's very JSON-like schema. So if you must be familiar with JSON as well, which is a very flexible way to store data as well. Although do note that there is a slight difference between JSON and what MongoDB uses, right? Which is called BSON, which is a more of binary representation of it, which again just means that you can do more than just JSON. Okay, in JSON you can only store numbers, booleans, and strings, right? But with the BSON you can also store things like dates, relations, object IDs, all those kind of things. So it's an extended model of JSON, you can say. Okay, so I'll just go ahead and give a little bit more into how MongoDB works. So there are three things you should know. So first, let's assume there is something called a database. Okay, a database is where you have all of your data. Okay, it's basically like a big giant folder. All right, and inside that you have something called collection. So this is a collection. Just create couple more. So a database might have multiple collection. A collection is basically like a set of data, okay, under database itself. While database is this large entity of everything, collections are like more specific, right? So I'll give you an example of what a collection might be named as. So one could be a users collection, one could be an orders collection, and you can also have maybe let's say sessions, right? And under each collection, you can then actually have some data. Okay, this is where at this level is where you have data. So this could be a user data, which is basically will look like a JSON. Okay, it will have things like ID, name, things like that. Okay, let me make it like this. Yeah. So ID will look something like this. Okay, then you have your name. It's going to be a string of something. Okay, maybe something like age. It's going to be a number, and have bunch of things here. Okay, you can also relate these documents as well. So you can link users and orders to in a way as well. So this can be linked in a one-to-many fashion, like one user linked a lot of orders. You can do that. One user linked to a lot of sessions. Okay, you can do things like that. You can create relations among documents, among collections as well. Cool. So that's a like very basic introduction to how MongoDB looks, or how you can basically use the database, right? Okay. Now there are multiple ways we can interact with the MongoDB database. Okay. The most common way or the most core way you can say is like using their own MongoDB library, right? So they have their own MongoDB driver which connects directly to your MongoDB database, and you can then interact with your database. So then there are some things called ORMs, right? ORMs are called are short for Object Relation Manager, I guess. So what they do is they you can basically think Okay, it's called an OEM. So it's a object modeling for Node.js. So this is what we're going to use. Basically, you can create models out of something like classes, okay? And then you can create objects inside of it. So it works in a very sort of object-oriented way, which makes it sort of easier to interact with your database, interact with your models, all of that stuff. Now, we can still use this, but a lot of things are abstracted in this thing, okay? So this is what we'll be using. Now, let's get started and add Mongoose to our project. Now, like any dependencies, we're going to bring up our terminal. We're going to install it like this, npm I mongoose. Here you can see they are requiring the mongoose here and connecting to database. Cool. So if you do not have MongoDB running, you can install that. Okay, one thing. Then you can also go ahead to mongodb.com, click on try free or sign in. You can create a account. You can create a cloud instance of the database itself and connect to it. That's what we'll be doing. But I will not be showing you how we can actually do this. This is quite straightforward. All right. And but what I will do is I'll give you a URL that you can use right now to use it, okay, which will be invalidated later for obvious reasons. But yeah, if you're coding along with me, you can use the same database string as I'm using. Okay, I think we have the dependency installed now. All right, so let's head back to the editor. And what I'm going to do is I'll create a new folder where I'm going to store these database schemas. Okay, so I'll call this models. And inside that, I'll create one model for our product. Okay, I'll call it product.js. So let's head back to the documentation. So this is how they do it. Okay, you create a model out of a schema. So this is what a schema is. Okay, and this is the name of the collection. So this is how you can create a collection. And once you have that collection, they call it cat. You can use the new keyword, create a cat instance, and then you can do save on it. So what then happens is from the cat being in your memory of your program, it goes into the database like that. Okay. So yeah, we'll also do something very similar here. So first let's require mongoose. Require mongoose. Once we have that, we'll create a schema like this. We call this new mongoose. It looks a little bit different than what's shown there, but this is how we're going to define our schema. So we'll use the schema class from the mongoose library to create our schema. So what do we have? Each document in MongoDB collection is going to have an ID by default. Okay, we do not have to create our own ID, an incremental number, or anything like that. So it will automatically create it for us. There is a way though, you can define it to false like this. So this way MongoDB will not create an ID for you, but we do not want that. We actually want it to create an ID. Now, let's go ahead and define what else we need in our product. Obviously, we need a name, and it's going to be of type string. Cool. Then we also had, if you remember, is in stock. It's going to be a Boolean type. What else? We can have. What do you have in your type def? We have, okay, we have ID, it's already there. Okay, we can have something like vendor, which is going to be string for now. Okay, once you have the schema, so this schema is something that Mongoose provides. Okay, when you're interacting with a MongoDB database, what Mongoose does is it uses this schema to validate if the data you're trying to store or the data you're trying to access actually fits in the schema. Okay, if it doesn't, it will try to throw an error. So that's how Mongoose kind of helps you Even though MongoDB is very flexible schema, or you can say at one level it doesn't even have an enforced schema, you can still make it behave it in such a way on a programming layer level. So this is what that is. So we'll create a model. So I'll call this product equals to mongoose dot model, and to this we're going to pass in the name, which is going to be products. Okay, it just has to be singular, and then this is going to be, we have to pass in the schema. All right, I'll export this product by default. All right, so that's how you can do it. I think we have to, yeah, we don't have to call new on this. So that's how you create a schema and a model. And yeah, now once you have your model, you can use it to create entries for product. Okay, now let's try to use this. But before that, we have to actually connect our server to MongoDB instance, right? So in order to do that, what I'll do is I'll import Mongoose over here. And just right here, I will do mongoose.connect. In here, you have to pass in the connection URL. So if MongoDB is running in your local, this is going to be the URL for it or connection string for it. If not, if you're running it on this place, MongoDB provided itself, okay, you can use a connection string that is provided in your instance. Okay, so it will look something like this. Let me pull it from my notes. It looks something like this. Okay, I'm just gonna change the database name over here. You can specify database name here. I'll just call this Amazon. Cool. So let's try to connect to this as well. So we can connect it like this. Yep, so it's connected. So if you have Mongo installed in your system, you will have this CLI as well, Mongo, to which you can pass in a string and it will connect to that. If you do not have Mongo installed, you can also install Mongo shell, through which also you can do the same thing. Okay, Mongo shell, you can just Google this, Mongo sh. Okay, and you can install it like here. Okay, you can install it from your binary. Cool. Okay, so let's see. Okay, so our database is connected. Now let's in the resolvers, instead of uh, adding the product into the array here, let's try to add it to the database itself. Okay, so in order to do that, we'll have to import our product model. So if I just do product, it should auto import it like this. Done. So now what we'll do is you can also do product dot create. So this is another way you can do this, and I'll just pass data to it. Okay, so then since this is an asynchronous call, we have to put dot then to it. So whatever the function we pass, it will get executed once the product has been inserted into our database. Okay, so what I'll do is once it's in, I think a better way to do this is to use async await. So we'll just do that. So instead of using dot then and chaining everything, what we'll do is we'll put await here. So what this means is that once data is like inserted, it go to the next line. Using async await, it makes your asynchronous code sort of look like it's synchronous. Okay, so we will not need this. All right, so I'll just gonna start the server and see how it's going to work. How did I close this? Okay, I'm in here itself. So I'll go to workshops. Okay, I have it here. All right, so let's start the server again. Node index.js server started, and let's head to the Apollo server. Invitation add product. ID is not needed. Okay, let's see what happens. It's true. So how do we verify if it's been added or not? So I'll connect to our database instance, and I'll just do show DBs, which means it will show me all the databases we have. You can see here the Amazon database is here, the one we didn't create, but we specified in our URL string parameter here, URL connection string over here. So which means that if the DB does not exist, it's going to create it for us. Okay, so we have to use that database. You will use the use command to switch databases. Okay, now we are inside here. Then you can do show collections to see what are the collections we have. So we have products. Okay, now we want to see what are the products we have. So what we'll do is db dot products find, and this will give us all the products we have. So you can see we have the name product 4 is in stock false, and yeah, you can see here this is the underscore ID. So this is the ID which is auto-generated by MongoDB itself. You can also do pretty to make it look more readable. All right. So we were able to insert. All right. So now let's also modify the products query to return products from the database instead of that hard code array, right? So under resolvers, instead of returning this, what we'll do is we'll do an asynchronous, make this an asynchronous function, and we'll call products equals to await. We will do product dot find. So you will notice this looks very similar to the command we just used in the Mongo shell as well. So this is the exact same command. Once we have that, we are just going to return this. So I have to make sure to change the type definition here because it's no longer ID, it's going to be underscore ID. It's going to be of type string. Yeah, and we do not need the ID here anymore. All right, good. Now let's restart the server and check it out. Just query the products. So awesome. We have the product 4 coming from the database directly itself. Cool. So we're able to get the products. Now let's build a little bit more functionality. Yeah. So how does Amazon say on a small scale really works, right? So let's assume that we're building a simple Amazon thing. What we what we would ideally want to do is we want to be able to get a cart, we want to be able to add some products to it, and then check out and place the order, and probably check the status of the order. Okay, we'll just try to achieve those bare minimum things. All right, so let's go ahead for that. So I'll just create one more model here for cart. Okay, so every user must request a new card for them to add their products. So we're keeping it really simple here without actually having user authentication and stuff. But yeah, we can certainly have something like that on different type of bootcamp, which is like, pretty much all about that, and but it would take longer, right? So okay, I'll just copy paste this and modify some things. So what would we have here? We would have something like a products array, okay, which is going to be of mongoose types object ID. What that means is it's going to be something like a relation to the products we have created here. Okay, so a better way to define this in Mongoose is to like this. You can do products type, which is going to be again Mongoose types object ID like this. This would make it an array, and you can also there is an option, I believe, ref or something, I think, or okay, let's just check the docs. There's a way we can specify that it's belongs to a particular collection. So what that allows us to do is when we want to populate it, basically, it will fetch those products from the database. So there is a way to do that. Let's see how. Check ID. Yeah, it's ref itself. That's right. Now it's going to refer the product. We can make this capital, think. Yeah. Okay. Oh wait. So products is going to for products, and this is the card, right? All right. And what else we can have in a card? We can have a card like a total value as well. Okay. So it's going to be a number. This is the total amount of product you have. So basically, then amount of total amount of all the products. So speaking of amount, we should have price for the products, obviously. It's very important. So type is just tells us what type of data it is, data type it is. So what I'm doing here is I'm specifying that product is a type of object ID, which is also an array. So when I put it in brackets like this, it means it's type of a array of type object IDs. So it's going to contain an array of object IDs. So this is a the shorter form of doing this is just giving the type directly like this. The reason we are not doing the same over here is that we want to specify more things about the type, such as referring to a particular collection. There are a bunch of other things you can do, such as making it require true. So what this means is that it when you're inserting something in this schema in card collection, it's going to make sure that there's this field is present there, or it will not allow you to insert it basically. So there are a bunch of options you can configure your schema with. Okay, so I'll just change the name here into card as well. Okay. Cool. So what we'll do now is we're gonna add a new resolver to that gives us a new card. Okay, I'll just call it get card or get new card. Async. First thing is going to be parent. Now we don't really need to have any arguments for this. So we're just gonna create a new card and send it back to the user. So what we'll do here is create a new card. We can simply actually return cart create empty object. All right, so that should work. So let's add this in type def as well. Right, so create type cart. It's going to be of it's going to have an ID obviously, and it's going to have an array of string, I believe, yeah, like this, and we'll define the mutation get new card, which will return a card. You don't have to have these parentheses if you're not taking any input. You can specify it like this as well. Okay. I think we're pretty much set here. Yeah, there's one more thing we can do. Just make it look more prettier. You can create an input as well. So inputs high products because it's an input, and also because it should not clash with other inputs or other types. We'll just put in name string is in stock is boolean, and then we'll replace this here like this. Okay, that should still work. Let's start the server. We do not have to keep restarting it, so I'll just use nodemon like this, so you can also do the same. So again, you must be familiar with this. NodeMon just basically restarts your server whenever there's a files change. And yeah, case in point again, there is in the newest version of Node.js, this is something now that's inbuilt. Okay, but we're not using the latest yet, so we're just gonna stick with NodeMon for now. Yes, install NodeMon, starting Node.js. So let's head over here to follow server. I'm just gonna, it got us the new card, so I'm just gonna execute this in a new tab here. So this is a mutation, right? So we get new card and the ID of the card. Yes, we got a new card ID here, as you can see. Awesome. And yeah, all right. Now that we can get a card, new card, let's also add another resolver to get a particular uh, yeah, we'll write a resolve, write a query to get particular card. So I'll say card ID string. It's going to return a card. Oh, and also you can see that this schema is like very string, right? Completely string. You cannot see certain type of syntax highlighting or anything. So we can like try to get that as well. What we'll do is we'll get the GQL. I guess we'll have to install a GraphQL tools for this. So that will sort of help us with the understanding, give us a syntax highlighting of SQL. So I'll just do that. So it's called GraphQL tools. I am guessing that might not actually need the GraphQL tools, but having an extension would probably just suffice. Syntax highlighting for GraphQL queries. I don't think it worked. Okay, I think you should have this in a GraphQL file. Yep, you can see now it's working. You can see the syntax is sort of being highlighted now. It's much more readable, I would say. All right, so what did we just do? We added a cart query which takes an ID string and returns a cart for that. So let's write the resolver for this now. So I'll head to resolvers, and in here I'll do cart. It's going to be an async. Can take ID like this. What we'll do is return cart find by ID. We'll pass in the ID like this. Okay. Now let's try to get that head out Apollo server. If I go to root, should be able to see that query now. Cart query is here. So I will do another workspace cart query cart, which is going to be it's going to take an ID here, which will be this. We'll pass it over here. ID and products. We have empty products. We got the product. We got the cart. Everything is working. Okay, so again, so find by ID is a method that is given by Mongoose. So you can fetch documents with their object IDs like this. Internally though, it is just using the find method available on the collections and then just passing this as a filter. Okay. Okay, let's go ahead and add a little bit of more features such as adding a product to a cart. Okay, so we do no longer need this products array. Let's remove this. And okay, now let's go and add a resolver which is going to add up given product ID to the cart. Okay, so I'll just do add product to cart. It's going to be an asynchronous function. So the data is going to be cart ID and the product ID. All right. So there are two ways we can do this. We can either first fetch the cart, push it to the array, then save it to the database. So that's one way. Another way is that we can write a little bit of a compound query which does two things in a one short way. Well, it fetches and updates in a single database transaction. So we'll go with the latter one. So it will look something like this: return uh, cart update one Or I think there is an update by ID or something. No, find by ID and update. Yeah. So first thing should be the ID itself. So it's going to be cart ID, and then you have the update query. An update query you can do. We're gonna use add to set here. Okay. We're gonna consider our products as a set. So the difference between considering at a set is set cannot have duplicate values basically. So we'll just do that. We'll just call add to set. And what do you want to add it to, right? We want to add it to the products. What do we want to add? We want to add the product ID. That's as simple as that. Okay, you want to add to a particular set. What is the name of the set? It's going to be products or array. What do you want to add? Product ID. Okay, so this would work. And let's also pass another option here. It's going to be new true. So this will give us the updated document, this option. Okay, I'll just explain this query once again. Find by ID and update is a Mongoose provided operation. What it does is it finds an object by ID, which is going to be cart ID. It then uh, does an operation, okay, or any set of operations that you provide in the second argument. So the operation we are trying to do is add to set. How do I know it's an operation? Usually they start with the dollar sign. Okay, there's a bunch of other operations available for different type of fields. For example, for a number you can have increment, decrement, probably not decrement, but yeah, you can do increment. All those things operations are available depending on the type of data you're dealing with. So yeah, this artist set takes in again like an object, which is a key value pair of what do you want to add to what. Then finally, there is a third argument is another object, which is basically options you want to provide to this operation. Um, right now, it's just a new true, which means that we will get the updated document after this operation. All right, so now that is done, let's add this to our type definitions. Add to cart, it's going to take in cart ID, it's going to be string and require. Another thing is going to require is product ID. We'll make that as required as well, and it's going to return cart. Save these files, see if we got it over here. Add product to cart, here it is. Okay, so I will add it in another new workspace. Call this mutation. Let's just add it here. Call it a mutation. Add product to cart. Right. So it's going to take in cart ID, which is string, and product ID, which is also string. And what will this mutation do? It's going to call add product to cart. Oh, what happened? I created another one. Okay, I see. Let's see what happens. We'll just do mutation, add, add product to cart. All right, this looks fine. What do we want in return? We want the ID and the products that were added. Let's define the cart ID and product in our variables. So this gets passed down to this add mutation over here, and which in turn passes to our actual mutations that we have defined in our code. So this is a mutation we created to interact with the mutations inside our server. Okay. All right. Cool. So how's it gonna work? We're gonna add a cart ID, which is here, and we will need a product, right? So let's fetch all the products we have here, and let's pass it here. Okay. Now let's run this. Add. Awesome. 7446 is the product that was added. Awesome. Uh, cool, cool, cool. You can see, no, doesn't matter how many times I execute this mutation, the product does not get duplicated over here because of the add to set we used. But if you were to use push, okay, which would just push all the things you send it to, we would see it getting duplicated. So that's why we use add to set, which is simply perfect for this kind of use case. Okay, great. So there's one more thing I want to show is that usage of context in Apollo server. So instead of having the card ID in here, we can set it as a header and use it in context. Okay, I'll show what I mean. So we can add a new header like this. So I'll just call it X Amazon card ID. Okay, so we will treat this as little bit like a identification of a user, all right? Because we do not have something like a user session or anything, so you can consider it like that. So that's why we'll use it in headers. So whatever thing is in header, that's basically it's passed down to every Apollo request we make. So what that means is we no longer have to use it over here and here. Okay, so again, we actually have to change the type def as well to actually match this type defs. We will remove product ID, and now the cart ID is removed from the query. How are we going to get this, right? We're going to get it from the headers. So let's see. Um, so we go inside our server setup here. Okay, there's a question by Vishal. Can I compare with Mon backend sometimes where it will easy to connect dots and learn faster? I'm not sure if I get that question right, but I think what you mean is to connect it connect it with the Mon backend. Oh, I'm not sure. Com- Compare with Mon. Okay, you mean compare it with the REST API? Yeah, we actually did that in the beginning of the first session. The comparison is again is like you would have bunch of routes, right? You would not even have this sort of studio where you can interactively test the APIs, work with it, and stuff like that. You'd ideally just if you are lucky, the backend developer would probably document it on something like Swagger or something, and then you can refer that and test it with something like Postman. Then try to understand how the API works, and then try to integrate it with your front end. But with using, GraphQL like this, a lot of things become easier. Things like, functions are easier to read and understand. Like, you see this thing, right? Add product to cart. Clearly tells you what it does. It clearly tells you what it needs. Clearly tells you what you can expect from it. So with REST, it's not like that. It's very REST is basically like a not like GraphQL, right? GraphQL is something on a different layer itself. REST is something it can still be pretty good if designed properly. So yeah, I hope that helps. Okay, so now that we removed cart ID from the add resolver here, we actually have to get it somewhere, right? So what we'll do is, so there is an option called context here, which takes in a function, okay? And whatever we return to this function, from this function, we can access it in any of our resolvers. Okay, I'll show what I mean. So for now, I'll just return, let's say, code is yellow. Now we'll see how we can access this in resolvers. So let's say in finding a card, the third option in a resolver function is the context. So I'll just log here context like this, and I'll also log context dot code. So if I try to get a card and check it here, you can see the context has this code yellow. So what we'll do is, in context, we will get this X Amazon cart ID and return it so that every resolver can access this cart ID very easily. So how can we do that? So context also gives us access to request and response, like so. And you can access a particular header like this, console.log request dot headers. Or is there a get header function? No. Okay. So headers, you can get the header value X Amazon cart ID, and let's see if that's coming there here. I'll just put another log here, cart ID. Okay. Let me run this and see we are getting the cart ID. Awesome. We're getting the cart ID over here. Okay, so you can see the request keeps happening here. So this is happening because of an introspection query. Okay. So introspection query is something the studio is doing to always be updated with the code or the schema. So whenever we change the type def, this introspection query updates it. So you can see here, it has all the queries we have, mutation type we have are being sent over here in this query. So that's why you're seeing this log so many times. But yeah, this does not affect performance in any way because this mostly just happens in dev server. Yes. So once we have the cart ID here, we want to send it back. Okay. So I'll just do cart ID like this, and we will have access to that. Awesome. So cart ID is now accessible. What we'll do is use this cart ID from the context inside our cart related resolvers. Okay. Here also, we no longer need it to be accessed. So we can just get it from the context. So it's gonna be context dot cart ID. Similarly, it's going to be context dot cart ID here. Okay, we no longer need this. I'll also remove it from here. You can see that how we can simplify this over repeating values, which are like sort of bind or bound to the session. So let's see if this works. Awesome, it's working. Cool. So one more thing we have to do here is when we're getting the cart, we're seeing the product IDs, but it would be better if you actually show the products itself So what I'll do is instead of string here, I'll first update the type def to product, and updating this resolver is not enough. So this just serves like a metadata, right? Our resolvers, which are the actual code that give us the data, they also need to change. So what we'll do is here, we'll call this populate function on product, product side. Yeah, we'll do the same over here, populate products. Awesome. Let's see if that works. Yeah, so specify, let's say take the name, it's null. We did not give the name, it seems. Is in stock, null. Something's not right. Name is here. Cards, product. Should be, I guess, capital here. Oh, okay, let's try again. This time. Okay, in which case we can also specify the places we populate. There's a way we can also like select as in what are the fields you want. So we want name, we want is in stock. Let's specify the model, just product. Okay. Oh wait a second. This is only for get new card, right? Should be changing it here as well. Okay. Don't think this is needed. Let's try again. Awesome. It's working now. We're able to get the name of the product, ID, and stock, everything in the cart. What's this? Yeah, in the cart query itself. Awesome. So we can then also add a function to remove an item from the cart. So we'll just do that. Just copy paste this function. It's gonna look pretty similar to this, except we'll only change the operation here, remove product from cart. Add to set, it's gonna be, I think it's gonna be pull, I guess. Let me just check the docs. Pull MongoDB. Yeah, it removes from an existing source of value or that match specified condition. So this will just do fine. Remove product from cart. We'll add it to the type defs. Okay, and let's do this. Let's call this notation remove, which is going to remove product from cart. Just take this same product, paste it over here. What's this? It's not allowed. We will just change its name. Where does it say that? Okay, let's just try executing this. Maybe it will work. Okay, let's run remove and products were removed. Okay, let's to confirm that, let's just get the cart again and see if the product is empty, and it is empty. So that's why you can add and remove from your cart and get cart. And if you do not have a cart, you can create a cart with the get new cart here. Okay, so you get a new cart here, and then you can set it in your headers. Where like how we have done here, it's Amazon cart ID, and that's how you can do stuff like tidy. It's an add products, and okay, we can add like this, then remove like this, and fetch it with cart. Awesome. So it's working as expected. So yeah, guys, that's how we can build this. Uh, we can fetch products, add products, remove products from the cart, and all of that stuff. So we also learned how we can, use context to basically share data between, similar data between all the resolvers. So as you can see, we got the cart ID from headers, request headers, and return it in an object which is now available across all the resolvers, right? So you can see here we added a product to add product to cart, remove product to cart, all these things. They're using the cart ID from the context, right? So we're not actually supplying that to these um, resolvers directly, and but yeah. So again, the use cases for this is like when you have specific fixed values for a session or a user, you can use like this. So you can use tokens. You can use tokens in your headers, extract it, get user data, store it in the context. You can do things like that. Okay, and yeah, then we also did models here. Um, okay, right, bunch of resolvers. So yeah, we're gonna push this to the GitHub repo as well, and yeah. So yeah, I guess this is time for to share a certificate link with you guys. We'll just share it right now. So you would need to fill this form so that we can send certificates to the attendees. So you can also scan this QR to enter your details for the certificate and we'll send it to you. So yeah, I'll just keep this up for a while. Thank you all for joining this session. And if you would like much more depth of this thing, GraphQL and Apollo, on how to use this MongoDB, all this together, either let us know in Discord or in the chat, and we will work on building a much more intense uh, bootcamp for this one. All right. Yeah. So like I said, this will be up for a while. See you guys in our next workshop. Thank you. Bye. Next live. Thanks for asking. So we will try to do this again, like how we used to do every week. Uh, yeah. So we want to know a bit more about MongoDB in depth. In depth. So yeah, we can have a session, workshop series just for MongoDB itself as well. Maybe the next one we can try that. Yeah. Yeah, no problem, Parthu. Thanks for attending. Hope to see you soon in the next live. Thank you, everyone. Bye. Take care.